Hello everyone, this is Clarix and today we are working with adding scientific notations that contains negative exponents. So in this case, we're going to practice two ways of doing this and you're going to choose whatever way works better for you. So one method that always works for any negative exponents in scientific notation is using the number line. So when we think about the number line, we think about the values being more positive when it's moving towards the zero. So even though this side is negative, this side is positive. By the way, I believe we all know that information. The more the values move toward the zero, the more positive it is. So in reality, we need to make these negative exponents as positive as possible. The way that we can do that is by making these exponents equivalent. Therefore, we can add these two coefficients. And I'm going to show you the way. So when we think about negative 2, when we think about negative 2, we know that negative 2 is around here. So we move to the left, negative 1, negative 2. Negative 2 is around here, right? That's an assumption or a possibility. So negative 2 is here. And when we think about moving from negative 2 to negative 6, we have to analyze how many times are we moving from negative 2 to negative 6, from here to here, basically. How many times are we moving? And we're going to count. So that's negative 3, negative 4, negative 5, negative 6. So negative 6 is going to be here. And we are moving negative 1 time, negative 2 times, negative 3 times, negative 4 times. So we know that we move from negative 4 times from negative 2 to negative 6. And therefore, in order to make these values as positive as possible, we need to change this to become negative 2, to the exponent of negative 2. Therefore, we need to move this value negative 4 times to the left in order to make the two exponents the same. So let's say we have 6.4. We're going to move that to the left from its decimal place 4 times. So we are moving 1, 2, 3, 4. We place the period there, the decimal place there, and we fill out all these values with zeros, okay, including those zero in the front side. So now we have that, and that became automatically times 10 to the negative 2 because we did that placement value of negative 4 times to the left the same way this value moved from here to here. Okay, we move that way, and therefore this exponent changed to the equivalent value of negative 2. Now we can actually add the other side, which is 4.2 times 10 to the negative 2. And when I say add, we focus on adding the coefficients, right? We say that 4.2 added to 0.12364, okay, it's going to be times 10 to the negative 2. So this here, we just use it once because we can actually combine it, right? It just combine itself. That way we can get to our final answer. And now we just add these two values. So we're going to have as our final answer 4.20064 times 10 to the negative 2. Okay, and since this value here is between, you can either round it, right? You can round it to this place, and just keep it as 4.2 times 10 to the negative 2. That is a preference for your professor. Usually, you just have to be careful that if this number is higher than 5, you need to change this number to a 3. And sometimes it's better to be precise with the answer. You have to be careful, look into your professor's preference. That is, this is a more precise answer, and this is an acceptable answer.